Hello and welcome to AutoKets. So in this lecture, I have brought you a very interesting exercise, and that is here we are going to see how we can just create, how we can just assemble, as well as how we can just simulate a spur gear assembly. So here you can see a prototype, or you can say that one example. And here what I have done, we have just created two different types of gears. Basically, one is a smaller one and another one is a big one. And basically what we have done, we have just created a joint that is getting rotate, that is making it rotated, just like what gear is done. So here in SolidWorks, it is very easy to create this per gear with the help of the toolbox components. So we are going to follow everything. But before going for the gear, you have to know about some of the terminologies related to the gear. Like over here, if I'm going to make this basically the two terminologies that is important over here. For that, I'm going to make it normal. And here the first thing is known as the pitch circle diameter. So there is a diameter that is running just from the center, or you can say that the middle of the teeth, and this is known as the pitch circle. So it is basically represented as dp. So this is a pitch circle diameter, and the topmost, you can say that this topmost part that is touching the topmost part of the gear, this is known as the addendum, as well as the bottommost part is known as the dedendum. So these are the three types of radius that is available in the gear. So first one is the radius of addendum, and another one is the radius of dedendum, and you can say that the pitch circle radius or pitch circle diameter. So these are the three radius that is running throughout the gear. Then one more important term is the number of teeth. So the number of teeth over here is known as this number of teeth. Basically, here you can see that this is a smaller gear, so it contains less number of teeth as compared to the bigger one. But still, if I'm going to rotate this, you can see that they are not colliding. Basically, they are running very smooth. That's because they have one thing in common, and that is known as the module. So what is module? Basically, module is the ratio of pitch circle diameter by the number of teeth, which is T. So this gear, if this gear is having the module as 2, so this gear is also having the module as 2, and accordingly we determine the teeth number and pitch circle diameter. So if the two gear will going to have the same number of modules or the same value of module, even if the number, if their sizes and the number of teeth is different, they will not going to create any collision. They will going to run smoothly, just like over here you can see that. So here the most important three terms is the pitch circle diameter, which is TP. You have to remember this. You have to remember the number of teeth, which is the gear teeth, and then we have the module, which is DULE, which is module. So we have to remember these three terms as well as this formula. So if you are finding out difficult to remember it, please take the screenshot. And basically these three terms are important for you to create the gear in SolidWorks. So let's just start how to create and how to use these formulas for creation of the gear. So here I'm going to start a new assembly. Yes, here since we are not going to create it directly in the part design, we are going to import it from the library. So it's not you have to go for the part design, you are going for the assembly over here. Just make it okay. And don't call out any of the part. You just have to go over here in the side panel toolbar, and over here you can see that there is a design library. If I'm going to click on this design library, you can see that this is a design library and there is a toolbox. So yes, the toolbox component is a part of design library, but we have to go inside this toolbox. And once you clicked on this toolbox, you can see that over here these are a different folder that containing the symbol of flags of different countries. Basically they are the matrices, or you can say that the standards that is provided over here. But since we are following the international system, so we are going to click on this ISO. So just double click over this ISO and you will see that inside this ISO you will find a lot of folder. Basically they are bearings, bolt screws, keys, nuts, o-rings, pins, power transmission, structural members, and washers. So these are the things that is present over here. We required power transmission, so we are going to click on the power transmission, and inside this power transmission you will see that there is a chain wheel drive as well as the gears. So just double click over the gear, and inside this gear you will see that there is a different kinds of gear. We require the spur gear, so we are going to click on the spur gear, click and drag it on the screen, and the moment you drag it you can see that a spur gear with any default size will going to be created. But as we know that we don't require the default size, we require the size that we want. So over here you can see that what is the configure component that is opening over here. This is basically, with the help of this, you have to configure your gear. So here you can find that this the two terms that we have talked, which is module that is present, which is the number of teeth that is present. So is in the module formula we have got the two terms, which is the number of teeth as well as the module. So we require the first option, which is the pitch circle diameter. So over here we have to create the pitch circle diameter, and accordingly we will get the teeth, or accordingly we will get the gear. So over here you can see that if I'm going to change the module, the gear size is going to be changed, and if I'm going to change the number of teeth, accordingly the gear size is being changed. So how to just find out the gear? For that we are going for the procedure, and that we are going to talk later on. But if I'm going to make it okay over here, this gear is ready for us for the use, and you can see that it will going to tell you to copy that gear. So yes, we can copy multiple gears, so but we required only one gear, so we are not going to create a copy. We are going to press the escape button, and we are going to come out from that tool, and you can see that we have the Spur gear ready. And over here in the feature manager tree, you can see that this is contains the proper definition of gear, which is ISO Spur 2.75 m, 83 teeth, 20 PA, pressure angle, as well as 12 phase width and all. So basically this whole specification is written, and you can just purchase out this gear if you are going to give this specification to your basically if you want to purchase from there. Now in the later we are going to see how we can just create the assembly of gear system. So let's just get started with that. So now we know that how to just import the gear from the toolbox component, and how to use the terms like module, pitch circle diameter as the number of teeth to define our gear, and to configure about the gear, what gear size that we want. So now we know that how to just get the gear. So now it's time to just assemble them and just create the assembly like this, where we can just simulate it and rotate it. So how to just make it? For that you have to go in for the part design, and you have to create a arrangement. Basically there are a lot of ways to just assemble the gear, but I'm going to follow a very easy one. So for that you have to create this thing. So this is the part that I'm talking about. Okay, so it is not open, so we are going to open it once more. So I'm okay. So this is the part over here. You can see that in the part design I'm going to create the structure like this. Basically this is how the gear will going to assemble, and basically this is the pitch circle diameter. So this is the DP of bigger gear, and this is the DP of smaller gear. So let's see how to create this thing. So for that I'm going to start a new part design, file, new, and I'm going to start a new part design, and over here I'm going to start a sketch. Make sure that you are working in MMGS. We require the MMGS over here. I'm going to select the front plane, and I'm going to create a center line first. So if we required a different gear ratio, so what I'm going to do, I'm going to create a line. You can take any value, but I'm going to take 100 over here. And from this part to this part, the value will be half, which is 25. So now you can see that this is 25. So the left part is over here, which is 75. From this part to this part, it will be going to be 75. So now we are going to use this endpoint to create a circle, and it will going to lie till this part. So this is one of the gear, and if I'm going to create a circle from starting from this as a center point till this part, you can see that these two are basically will going to be the pitch circle diameter. So this pitch circle diameter will be from this part to this part, it will be 75 into 2, which is 150. So this is 150 and this is 50. So in the module, we have got the DP value, which is 50 over here. Now it's time for the module. So we are going to follow one random module. We are going to take a module, especially when you are going to create a gear, you will get the module from the design department or analysis department. But here we are going to take module as 2. So we have two things over here. We have the DP value, which is 50 for the smaller gear, and the module will going to be constant, which is 2. For the bigger gear, the DP will be 150, and the smaller gear, so for the bigger gear, the module will be 2. Now it's time to get T. So for that, what I'm going to do, I'm going to make it exit. So make sure that you are going to exit the sketch. Then only it will going to be imported into the assembly. So make sure that just do the exit and just save it. So I'm going to save it. I'm going to select a save, and I'm going to select it with different. I can just write any name, but we are going to have a name like this. Just make it save, and now it has been saved. So we have done the exit sketch. So now it can be acted as a part, and we can just call it in the assembly. Just go for the new, just create a new assembly, and over here you can see that with different gear ratio is available. So here we have to just call this like this. Now we can just create, or we can just import the gear, and we can just attach this to this references to create the gear joint. So for that, I'm going for the design library, and from here we are going to select the Spur gear, and we are going to take the module as 2 and the number of teeth. So we have to calculate the number of teeth. So for the smaller gear, let's just calculate it. Module is equals to dp by t. So we have the module value, which is 2, is equals to the dp. The dp value, we know that for the smaller gear it's 50 divided by t. So t, we are going to make it above 50 divided by 2, which is 25. So for the smaller gear, we require the module as 2, and the number of gear will be 25. So just make this one as 25. So the moment I make it 25, you can see that it size become actually what will going to fit inside this reference. Just make it okay, and this is one gear that we want. We don't want a copy, so we are going to make it escape, and we required a new gear for the bigger one. So I'm going for the Spur gear again. I'm going to import it, and for the bigger one, similarly we have to calculate the t value. For the bigger one, the radius is 150, or sorry, diameter is 150 divided by 2. So for the bigger one, the teeth is 75. So here we are going to make this as 75, and the moment I make it 75, you can see that it will going to have that value ready. We don't want a copy, so that's it. Now how to assemble it? For the assembly, we required a mate. So I'm going to click on the mate, and let's see how to just select a part. So I'm going to select this face and this reference. It will going to attach this to the reference. Just make it okay. And now I'm going to select this part and this center point, and it will going to attach it till over here, but it will going to make it coincident. We don't want coincident, we want concentric, and it will going to come right in the middle. You can see that. The same we are going to do for this. I'm going to select this face and this face. It will going to attach it with this reference. And then I'm going to select this center point as well as this point. Make it concentric, and you can see that it will going to be attached. They are properly aligned. If it will not going to be properly aligned, you can use the move and rotate to make it aligned like this. If you want to color out this gear, you can just go for the color. You can just select colors, like I want this to be yellow. So I'm going to select yellow, and this to be red or green. So I'm going to select green or blue over here. Just select a blue. Just select a part over here. Just select this one. Just make it okay. And you can see that the gear has been done. But if I'm going to rotate this, you can see that it is not actually rotating with the reference, like just like a gear. They are individually rotating. That's because here we have to create the gear joint between them. So how to make it a gear joint? For that, you have to go for the mate, and from here you have to go for the mechanical mate. From here, just go for the gear. This is the gear, and for the mate, I'm going to select this face and this face, and here the ratio. So this is the gear ratio along which it will going to rotate. So for the gear ratio, you have to provide the number of teeth. If you know about the gear ratio, they are basically the T1 upon T2, T1 upon T2, or the D1 upon D2. So, or D2 upon D1 basically. So there are different ratios. So we are going to use T1 upon T2. So here T1 for the smaller gear, it is 25 we have taken, and for the bigger gear it's 75. Just make it okay, and now we are ready. It is now being rotated just like the gear. You can see that. If I'm going to rotate it, you can see that it is rotating like a gear over here. Now let's see how to simulate it. So for the simulation, you have to go inside this motion study. So this is the motion study. Just click on this motion study. From here, we have to apply a motor. So there's a tool expand option. You can just expand it and you can see that the expansion will going to open. From here, there is a motor. Just click on this motor. And for the component, you have to provide motor on one component. And since there is a joint in between the other component, it will going to rotate it simultaneously. So I'm going to select this as my rotating component. So you can see that this is showing the direction of motor. If you want to reverse this, you can just click on this and it will going to be reversed. From here, you can just select the RPM. Once done, you have to make it okay. And now if you can see that in the motion manager, there will be the some till the a time it will going to show up. If I'm going to make it play, you can see that it will going to be playing. To make it more smooth motion, you can just select from here, you can just select basic motion and you can see that it will going to be rotated perfectly like this. If you want to increase the time, you can just increase it from here, but you have to calculate it. So there is a calculate option. You just have to press it and it will going to calculate that values, basically motion like this. And once it is going to be calculated, you can just play it again and again like this. You can even increase the speed from here. If you want to increase it to 2 times, you can increase it and the gear will rotating now fast like this. You can even change the loop mode. You can just make it in a loop and you can just play it and you can see that now that you don't have to play it again and again. It will going to be in the loop mode. So it will going to rotate it after this. So this is all about the gear joint. I hope you have liked it and all the steps. If you have any doubt, you can just ask us on the comment section. We are going to clear it out. And if you find this video valuable, then please like this video and subscribe our channel for the updates like this. Thank you.